My topic for today is schema matching. Schema matching is the process of identifying correspondence between elements of different schemas to facilitate data integration, exchange, or migration. It aims to find similarities between attributes, tables, or entities in disparate data sources. An example of this is we have two databases. We have database one, we have the source. For example, this is the customer, which includes attributes such as customer ID, full name, phone number. Whereas we have another database, which is a target, which has a name of a client or the- named after client. So this could have attributes like client ID, name, contact number. So schema matching would identify that customer ID or cost ID and customer ID would be the same. Full name and the name would be identified as matching. So the phone number and the contact number could be identified as match as well. Key aspects of schema matching. First, we have input schema. The source and the target schema need to be compared. Next, we have as matching process, identifying similar or equivalent attributes using various techniques. Third is output mapping, the set of match schema elements used for integration. Example of input schema. For example, we have two databases, which is the Amazon and the Temu. So for example, for Amazon source schema, we have this field names, customer ID, full name, email address, phone number, order number, total price, and purchase date. Whereas the Timu has, as a target, has the following field names: customer ID, name, email, phone number, order number, amount spent, and order date. So in which we got here, that's the data type for each field, and we have also example values. For example, for full name, we have Juan de la Cruz, whereas the other one is Juan de la Cruz. For email, it's just the same data. For handling data differences, so here Amazon and Timo database schema are compared. So we have the field for customer ID and customer ID. The difference is the big letter caps lock letter for ID, which it's noted that it is the same customer across different platforms. So they have full name and they have name. So it has different naming conventions. So why this is important? Why we need to compare input schemas? So this is important because of um, there could be multiple platform for shoppers that may have different transactions across apps. Another is schema matching help unify customer records while keeping order details separately. And the third one is company needs to track spending per platform for accurate financial support. Another here is another is example is for process matching process. So we have here different techniques in matching processes or process. Example is exact matching. So we compare or we match customer ID and customer ID. The field name is exactly match. Next we have is synonym matching. So this one is full name and the name. Most likely the fields are synonymous. Next we have is numeric or ID matching. So we have order number and order ID. Number four is fuzzy matching. Example here is Juan de la Cruz and Juan de la Cruz. It has like different naming convention, but the content is the same. It both contains Juan as first name and de la Cruz as last name. The difference is the de la Cruz is the first letter is capitalized or in big letter. Unit convert the fifth one is unit conversion matching. So we have here total price in dollars, and the other one in TMO field is amount spent is 1,450 in peso. So date format matching. So we have here purchase date and we have the order date. So the format is it comes first with Amazon. It comes first with the month, the day, and the year. However, with Timo, it comes first with the year, month, and the day. So the third one is output mapping. So mapping is okay. Same database is being compared. So Juan de la Cruz is customer ID is 1 or 101. The name, email, and phone number, and order ID under Amazon. So it has here 5,000. So here in output mapping rules, so here where data is compared for transformation, for example, customer ID from Amazon OR, customer ID from Amazon versus the customer ID from Timo. After the mapping, we have here a unified output data, which is 101 De La Cruz, customer name Juan De La Cruz, email address, and the phone number. Types of schema matching. First is element level matching, compares individual schema, example column names, and data type. Structured level matching, consider relationship between elements, example the parent relationship in hierarchical data. The semantic matching uses meaning based on the techniques, example ontologies, synonyms. As like example, synonym matching earlier is this the names to align the schema. This instance base matching use actual data values to infer correspondence. Example matching by analyzing common values. Schema matching techniques. First, we have here name-based matching. As example, um, we're going to compare the attributes by its name. So we use exact matching. On the previous example, we have customer ID and customer ID. Synonym detection is full name and the name. String similarity is customer ID and customer cost ID and customer ID. Data type matching aligns attributes based on data types. Example, integer versus character. Varchar or varchar. Domain based matching matches attributes with similar values domain, example zip code and postal code. Number four, constraint-based matching. Use schema constraint, example, primary case, foreign case, to infer relationship. Number five, matching. Number five, machine learning and AI-based matching. Leverages patterns recognition, NLP, and deep learning for automated matching. Number six is instance based matching, compares actual data values to detect similarities. Example, New York appearing both in city fields. So we got here challenges in schema matching. So we have is the heterogeneous naming convention, structural variation, data type differences, synonym and homonym scalability issues. So we also have here schema matching tools. For schema matching tools, these are the following popular tools used for schema matching. So Open Refine, use data cleaning and matching. So we have also Coma Plus Plus, a tool specifically designed for schema matching. Microsoft SQL Server Data Tools supports schema comparison and mapping. Apache, NiFi, and Talent. So this is a ETL tools with schema matching capabilities. So we also have machine learning models, customer AI based solution for automated schema matching. Importance of schema matching. So we have the following: facilitate data integration, which ensure seamless emerging of data from different sources. Second, we have support data warehouse, standardize and align data before loading into warehouse. Third is enable data interoperability, helps in making different systems work together. Enhance data quality, identifies inconsistency, and standardize format. And we have aids in system migration, critical for merging legacy database with new ones. Important. So in data matching or schema matching, it is important that crucial step in data integration. So schema matching is crucial in data integration. It also ensures accurate alignment of disparate data sources. And lastly, it is essential for automation and improve accuracy. Ex- Example is big data expansion, AI driven schema matching techniques. So I have here an activity for schema matching. So this could be the file can be downloaded, and in the file it includes source schema, which is the original data fields. We have the target schema fields with different names, and the mapping activity answer sheet. So to match the answers in its field. So once you're done, you may email your activity to my end. But prior to we before we end, um, I'm going to explain the content of the file. We have the source schema and we have the target schema. For the source schema, for example, this is Amazon, and the other one is the target schema, which is the Timo. So as you can see, they have different naming conventions: full name to name, email address to contact email, and phone number to contact number, order ID to transaction ID, total amount to amount, order date to transaction dates. So as you can see in this example, for we got here customer ID, we have here the name field for the source schema. So for example, we have here ID, customer ID for the source, and match with client ID. And what is the technique used is name-based matching. So here, for the full name, you could have here full name, and we have here the name, and whatever matching techniques you think it suits. So that ends my presentation. So thank you for listening, and good morning.